Good morning. Today we are going to talk about the law of cosines. This is actually the last stretch of our trig applications unit. We'll talk about three very important laws that are on your Regents reference sheet and how to use them and how to apply them to different real-world situations. So you need to have your Inspire document open from Unit 8, number 10, titled The Law of Cosines. And once you're there, go to page 1.2. And here we go. The Pythagorean theorem and SOHCAHTOA are useful when we have right triangles. But what do we do with a triangle like this one? This is not a right triangle. I still need to know stuff. It could be a piece of land, and I need to know the length of this side based on other information, or I may need to know the area of that land if I plan to buy it, things like that. So we clean up, we finish up our trig applications unit by understanding that most triangles in the real world are not right, and that's the beauty of the trig we know now. We have three more laws that handle non-right triangles and will help us solve problems using them. So let's go to page 1.3. Here's your law of cosines. It states a squared equals b squared plus c squared minus 2bc cosine a. Now if you take a glance at your reference sheet, you'll notice that it might look slightly different. And I want you to take a second to look at your reference sheet and figure out what is different about the way I've presented the law of cosines here and the way it's given to you on your reference sheet, so we can have a conversation about that. Okay. So here's your Regents reference sheet. We've already talked about lots of the different formulas on there and what we can do with them and how to use them to help us solve different kinds of problems. Today our focus is this law of cosines. Again, a squared equals b squared plus c squared minus 2bc cosine a. The thing I want you to notice between this formula given to you on the formula sheet and what I gave you here on your Inspire is I add parentheses, and I think it's imperative that you add parentheses. Students who do not put parentheses after the minus sign, students who do not encase the 2bc cosine a, or whatever your variable names are, after the subtraction sign in parentheses, will get these problems wrong. It's a PEMDAS thing. The parentheses remind you about order of operations and that you need to deal with that stuff first. And that 2 times b times c times cosine a is all one chunk of information. It's all being multiplied. It all goes together after that subtraction symbol. So my first warning to you about your Regents reference sheet is when you copy this formula down, and you can copy it down. You're not supposed to memorize it. It's not meant to be memorized. It's given to you on the Regents Day on your reference sheet. But when you copy this down, make sure you add in parentheses, and I have a hard time drawing in parentheses, after your subtraction sign. Okay. So, the next part of your notes asks you to open your lab packet to day 10 and complete the example problem with me. Then we'll come back to this document. Our packet day 10, reminding us of the law of cosines. Let's write it. The more you write it, the sooner you'll get used to using it. From our Regents reference sheet, the law of cosines is a squared equals b squared plus c squared minus, again, I insist you add parentheses after the subtraction sign, 2 times b times c times the cosine of angle. Okay. Things I need to remind you of. The way we name triangles in math class. The angle names are in capital letters. So this might be angle A, this might be angle B, and this might be angle C. In lowercase letters, we name the side opposite its angle. So here's angle A, capital A. When I look directly opposite it, that has side little a. Here's angle B, capital B. When I look directly opposite it, that is side B, little b. And here's angle C, Look directly opposite it. There's side, little c. So now you understand where these letters are coming from. Also notice the pattern here. A squared, this side squared, is equal to, I use the other two sides all throughout the formula, and then the cosine of the angle that's named after its side. So these letters have to match up. And the reason it's so important that you understand the pattern is that not every triangle is named ABC. In this example, we have a triangle named RST. So let's practice with it so you can see the naming of our triangles and using our law of cosines. So it's always wise to draw yourself a triangle, RST. In this case, little r, that means side r, opposite angle r, is 11. Little s, that means side s, opposite angle s, is 12. And the measure of angle T is 120 degrees. Okay. Obviously my picture doesn't make sense. It's okay, we didn't know in advance. If it really bugs you, you could make your picture make sense and make T an obtuse triangle, an obtuse angle, and that's okay. But it's not necessary. Oops. There you go. Okay, our law of cosines from our Regents reference sheet says a squared equals b squared plus c squared minus parentheses 2bc cosine A. We don't have triangle ABC. We have triangle RST, so we need to make good substitutions. Well, the only angle that I have any information about is angle T. So instead of talking about cosine A, my formula will talk about cosine T, which means the side I'm looking for, or can find in this case, is little t squared. The other side names are r and s, so that's how I'll replace b and c with r and s consistently through the formula. So t squared equals r squared plus s squared minus parentheses 2 times r times s times cosine t. So the Regents reference sheet gives you one version of the law of cosines. You need to be able to replace it with the appropriate variable names and rearrange it as necessary to help you solve a problem. So once you've figured all of that out, the rest of this is just plugging in numbers and using your Inspire to get an answer. So if you're good at substituting and want to fast forward and check your answer against mine, that's fine. I think maybe for this first video you would want to watch the whole process, but that's entirely up to you. So here we go. T squared equals r 11 squared plus s 12 squared minus parentheses 2 times r is 11 times s is 12 times the cosine of 120 degrees. Okay. Now, please keep in mind that when we know values from our unit circle, these kinds of problems can show up on the non-calculator part of your exams. Cosine 120 is a child of 60, and cosine 60 is 1/2. So in quadrant 2, you see we still need to know all this unit circle trig stuff. Cosine is negative. So the cosine of 120 degrees is negative 1/2. And so we can do this math from here without our Inspire. 11 squared is 121, 12 squared is 144, minus 2 times 11 is 22 times 12 times negative 1/2. Order of operations tells me to do parentheses first, so I'm going to clean this up. And the nice part about this negative 1/2 is it'll make these numbers smaller. So it really doesn't matter. I'm going to replace 2, or divide 2 into 12 and get 6. And then off to the side, 22 times 6 is 132. Now it's negative 132 because of this negative 1 left over. So in my parentheses, I have negative 132. Copying the rest down, 121 plus 144 minus negative 132. So we have 121 plus 144. Subtracting a negative is adding 132. We can add those up off to the side. If this is a non-calculator problem, which it will be, 2 and 4 is 6, plus 1 is 7. 3 and 4 is 7, plus 2 is 9. 1, 2, 3. So t squared is 397. We want to know the value of side t, the length of side t. I'm going to do squaring by square rooting. In this case, it's just the positive square root because it's a side length and sides can't be negative. So a non-calculator problem, boom, you'd be done. Now if we do go back and read the directions, it says find the length of side t to the nearest integer. That is a hint that you want your calculator to help you approximate that square root. So go to your Inspire, grab a scratch pad, and we'll say the square root of 397, and we get to the nearest integer 20. So t is approximately 20, rounded the way we were asked to round. Make sure that looks like a t, not an a. And that's it. That's how the law of cosines works. You get your law from your reference sheet, you substitute in appropriately, and either know your exact values from your unit circle, or if necessary, use your calculator. I want to remind you about calculator use, and that at this point, at this stage right here, we could have gone directly to the calculator if this were on a calculator part of the test. And because we are super careful with parentheses and our substitutions, we could type this in just as it looks, and I will show you that as well right now. So we are going, and we're going to type that entire expression. So 11 squared plus 12 squared minus parentheses 2 times 11 times 12 times the cosine of 120 degrees. Now, I'm always going to hover up here and make sure I'm in degrees mode, and I am. If you like to be extra careful, you could always say Control the book and grab your degree symbol, and that'll ensure that you are in degrees mode. Or if you want to be extra careful and you really know your unit circle well, which you all should, you could just type in -1/2 here, because that is the cosine of 120. Okay, and when you press enter, there's your 397, just like we got without our calculator. And from there, of course, you would square root your previous answer and be done. So we've done the example problem. It says let's go to page 1-4 now on our Inspire document. Click and drag any point on the triangle on the next page to watch the law of cosines in action. And this is just to show you that it always works. Here I've taken the value of a and squared it, and then that should be equal to b squared plus c squared minus 2bc times the cosine of a. So for the particular triangle that's on my screen, your Inspire might be different. I have 544 to start. But what I want you to do is to grab any point. Here's point B. Remember, you click and hold. And when you move that triangle and change its size, the side lengths change appropriately, the angle measures change appropriately. But if you keep your eyes at the bottom of the screen, a squared is always equal to b squared plus c squared minus 2bc cosine a. The law of cosines does hold. And you can do that with any of your points. So take some time to do that, if for no other reason than to just convince yourself that this isn't some crazy one-shot deal. This is a formula that will always work. And that's it. Have a great night.